Similarly, we can have a grid layout. For example, we have these buttons. If we look at the output of this code first, we have this grid layout demo where we have these buttons in a 3 by 2 matrix form, and when we click this, the grid layout is toggled to a 2 by 3 matrix. So we are basically just demonstrating the grid layout where we can have buttons in the form of grids, and we can have the grids in any matrix formulation. For example, this is a 2 by 3, a 3 by 2 matrix. How do we do this? We create a grid layout frame by extending the JFrame, and we implement the action listener interface in this frame. Again, we have an array of buttons. We have the names for the buttons 1, 2, 3, 4, 5, 6. We have a variable, so if it will choose the type of grid that we want to choose by clicking any button, the container that we have on the frame. And we want to have two kinds of grid, two kinds of grid layouts. The one layout is a 2 by 3 layout separated by gaps of 5 pixels, and the other layout is a 3 by 2 layout. As we just saw, we initialize our container object, we set the layout to grid layout 1 by default, so this will be a 2 by 3 formation of the buttons. We go through the buttons and assign names to our buttons, and we display these names and associate the action listener with each button. The action listener toggles the buttons, the grids between the two layouts. So if it is true, we have chosen a layout, we choose layout 1. If it is false, we choose layout 2. If it is false, we choose layout 1. And by clicking the button, the toggle is shifted to or assigned to an opposite value. So we again initialize an object of our frame with the parameters that we want to set it, with the properties that we want to set the frame to. And if we run this, we can see that we have a grid layout in this format. By default it is in this format, and when we 3 by 2 format and we click on the button, we are just clicking. But the idea is to create that to demonstrate that we can have components in a grid layout in our frame. Similarly, we can use a panel frame that, if we look at the output of this one, so we have a grid of buttons, and then we have those buttons as a border layout. So we are using two layouts in this demonstration. So we initialize an object of the panel and an array of the buttons. We have a certain set of buttons and we want them to have a grid layout, so we have 5 buttons by setting, and we set the layout through the length of the array of buttons in a grid format. So we have a grid of 5 buttons now. The buttons are added to the panel by calling the add method of the jpanel object, and then we add the border layout, and towards the bottom of the south we'll add the buttons towards the south of the or the bottom of the panel. So basically this means that we have the panel of the buttons that was arranged in the grid layout, and that then we added the entire panel to the bottom of our frame. Similarly, we initialize the object with the properties that we want to add to our frame, and as we just saw, we get a grid of buttons initially, and then we add that grid to the bottom or the south of our frame or panel. Custom painting, we can use the JPanel for custom painting on our form. Let's say we can create an area for custom painting, drawing inside a panel. We want to draw something randomly on a panel, then we can use the JPanel for that purpose. It overrides the paint component method. We'll see that in a while. So we have a public void get a paint component method, and it has an object of the graphics class that we'll import. And what this line does is note that call the superclass version of paint component as the first statement in the body of the overridden method to ensure that the component displays correctly. And we don't make a direct call to the paint component method in our code. We do it through the call to the superclasses paint component method. This method is called automatically by Java runtime whenever the JPanel area needs to be refreshed. For example, if when the frame is first created and displays, this method is called automatically to refresh the painting area for us on the JPanel. Or when some platform on some platforms the JPanel area is covered by maybe other applications, and when we come back to the JPanel or the JFrame, this method is called automatically and the area is refreshed for us for painting. Or when the user makes a change to the JFrame size, and this method is called automatically to refresh the painting area. For example, we have a class myPanelExtends JPanel, and we call this method public void paint component, and this is the first thing that we should do in our class, that we call to the in the paint component method we call to the superclass paint component method by passing the object of the graphic class. Then we can use the object to draw things on our panel. The graphics object is supplied by the Java runtime to the paint component method whenever the JPanel object needs to be displayed. So that is what the graphics object is used for. It is supplied by the Java runtime to the paint component method whenever the JPanel object needs to be displayed. Inside the paint component method, the graphics object can be used to draw things. So we'll be using the graphics classes object to draw things on our panel, and we'll see this in the example as well, that we will be importing the graphics class and we'll be using the object of the graphic class to display or draw things on our forms. Super.paint component is always the first statement of the paint component method, so we need to remember this, that this will be the first component or the first statement in our paint component method. This method ensures that the JPanel area is cleared before any painting is done. For example, we have this example which demonstrates how we can draw randomly on a panel. If we look at what does it do initially, so we have this border layout maybe to display a message on this the JPanel form, and if we try to drag our mouse on this area, what it does is it draws random points on this panel, and this is what we can use a JPanel for, that we can use it as a painting area if we want to draw randomly on the panel. So if we look at the code over here, we have these classes that are imported. We have a graphics class and we have a point class. We have the mount event and the mount motion listener, as well as the labels and the JFrame, etc. So what we do is we create an object of the JPanel, a subclass of the JPanel class. Initially we have append count the number of points, that we want to draw. We have an array for point objects. So maybe let's say these are 10,000 references to the point class. And in the constructor of this JPanel, again we are using anonymous inner classes and event handlers that we will be covering in our next upcoming lectures. But what does it do is it stores the drag coordinates and repaints those coordinates. So if you are drag our mouse on the area, it gets the point at each point that we are dragging our mouse on, and it increments those points and repaints the area, repaints the JFrame, and that is done through this method that we are using over here, the paint component method. We have an object, as we saw earlier or discussed this. It clears the drawing area for us whenever we it refreshes the drawing area for us, and then we can draw all the points in this loop. So the action is handled by the action add mouse motion listener, and what it does, it catches or it counts the points, or it gets the points where we are dragging the mouse and then it draws ovals on each of those points. These are the positions of our ovals, and these are the sizes of our ovals. Fill oval is a built-in method in our graphics class. We'll be looking at these methods in a while, that we can use to draw circles or ovals on our painting area. Again, we initialize our object of the paint panel class. Or here we have a border layout that is centered where the drawing will be performed, and then we have a border layout. We have used a border layout towards the bottom of the drawing area or the form. And as we saw in the example, that as we drag our mouse in this area, it draws certain small ovals in this area. As you can see, it's a default color, that is the black color. We can change the color as well, but we are using the default color at this point. We can also use the graphics and graphics 2D classes for custom painting, and it provides us with a bunch of built-in methods that we can use to draw objects on our panels or frames. So we have a graphics method that is an older version of the method in Java 1 and 1.1. We use Java graphics 2D method, that is a newer graphics context, a newer method, a newer class. Although paint component takes a graphics object, what you get is really a graphics 2D object. Basic methods for painting graphics and graphics 2D are in graphics and graphics 2D classes are draw line, clear rectangle, draw 3D rectangle, fill 3D rectangle, draw arc, fill arc, draw oval, fill oval, draw polygon, fill polygon, draw polyline, draw string, etc. There are loads of methods that we will see in the examples as well, and demonstrate how these methods work. Support for arbitrary shapes, for example, a single draw method, a single fill method can draws or fills anything implementing line 2D, rectangle 2D, round rectangle 2D, arc 2D, ellipse 2D. All of these different shapes can be drawn with the help of draw method. We also have different strokes interface, for example, basic stroke, which have pen styles, different lines with patterns, giant styles, use set stroke, fill patterns, implement the paint interface. For example, we can have solid fill, default color space as RGB, color red, color green, color black. We'll see this in the examples that how do we use these colors for our shapes. So we can have an object of the color class initialized to a certain color between 0 and 0 to 55. This is a combination of RGB colors. Similarly, texture paint tiles a picture, repeats as necessary. Gradient paint a gradient between two colors. So the first one can repeat a color, and the gradient will show us a gradient between two different color. You can use set paint or set color method. You can also draw shapes. In order to draw in the JPanel area, we use the graphics object. The graphics object is supplied by the Java runtime as a parameter to the paint component method. The graphics class contains many instance methods. For example, we have draw line. The draw line method helps us to draw lines on our JPanel. X1 and Y1 show the initial position or initial point of the line, and X2 and Y2 will show the end point of the line. Similarly, the direct method will draw a rectangle in the JPanel area. Integer X and integer Y will show the starting position of the rectangle. We measure the position from the top of the panel in graphics. Y will show the distance from the top, and the X will show the difference from the side of the panel. And the width and the height, these two arguments will show the width and the height of our rectangle. Draw oval, the XY position of the oval and the width and the height of the oval. It will draw an oval on the panel. Fill rectangle will fill will draw a filled rectangle in the default color or the color that we have set already. Fill oval will draw a dark oval by default, or will draw a filled oval with colored oval with the color that we have set already. Draw string will draw a string. It will have a text argument and the position of that argument on the JPanel. Set color method is used to set the color of our drawing objects. For example, when we set the color and then we draw a fill oval, then the oval will be drawn in that color. We can get the color or we can set the color to one of these colors as well through the object of the graphics class. Once we have practiced the examples that we'll see in a short while, you can try and draw these diagrams or these graphics in your JPanels as part of your practice and exercise. That will conclude our lecture 22. We will look at examples, usages of these methods, and different how we can draw different shapes and graphics in Java.